Hi, my name is Jason Koff, and I'm an associate professor at Tennessee State University. In this video, I'm going to be talking about different types of drones, as well as some of the different types of sensors or software that can be used with drones, along with their costs. So to start off with very generally, the main types of drones include fixed wing and multi-rotor. The fixed wing drones generally are going to be able to cover more area within a given amount of time because they fly faster. Also, they have a longer battery life, and so the flight times themselves are longer. So that's the basic difference. The fixed wings also usually end up costing more than the multi-rotor drones. So the multi-rotors aren't going to have as much flight time. They're going to be able to cover about half the area that a fixed wing drone can cover, but they are going to be cheaper. So this is an example of a fixed wing drone. You can see it looks like your typical kind of airplane uh, configuration, and you can see the lower uh, image. This is how you basically let them take off. You kind of throw them in the air. They're called hand release, and then they take off that way. They don't have any real landing gear or anything that you would typically think of with a normal airplane. So this is that drone that I showed on the previous slide. It's a SenseFly EBSQ. It's got a price tag of about $7,500. And it does come, in this case, this comes with a multispectral camera, and we'll get into this a little bit later. But essentially, there's a number of different sensors that are part of this camera. You can see on the sensor in the lower right-hand corner, and they basically take images at different wavelengths of light. This is another example of a fixed-wing drone. So the one that I showed previously didn't have any sort of landing gear associated with it. It didn't have any rotors or anything that you see in this one. And so this one has the fixed wing configuration, but it also has some rotors. And the reason for this is because if you're flying a plane and you're taking images and pictures, and that's going to be, all those sensors and cameras are going to be located on the bottom of the plane, the aircraft. And so since some of them don't have the landing gear, when they land, they kind of land and roll across the ground, across the surface on the surface of the underside, the underbelly of the aircraft. And so if that's where all your sensors are, there is, a chance that, you could have some issues with those sensors. You could have some scratching or things like that, and that could be a problem. So with this case, the hovering that's produced by the rotors and the multi-rotors that are on this aircraft allow it to basically take off and land a lot more safely when it comes to some of those sensors and cameras. So with this specific one, again, the price tag is about $7,500, similar to the last one. And then you can go up from there depending upon what sort of things you add to it. Different types of sensors and software and things can obviously make it, as with anything else, it can make it go up to higher values. And this is just another example of a fixed wing. This is a kind of a startup company. I don't have a price on this one, but probably similar to the other two that I showed. It's got a similar area of coverage, and it's just one more example of these fixed wing drones. So this is an example of a multi-rotor drone. I think a lot of folks are familiar with these. They've seen them around. This is from the company DJI, and so they make a number of different types of multi-rotor drones. So I'm going to show a few different ones. This one is a little bit more on the higher end, just because this has some plug-and-play features with using different cameras and being able to switch them out and do different things. And you can see there's some higher prices associated with that as well. So this is an example of a multi-rotor drone that's got a little bit better price point than some of the other things that I've been showing. This is the DJI Phantom 4 Pro. And so this one, it has a flight time of about 30 miles, 30 minutes, and a maximum speed of 45 miles per hour and a range of 3 to 5 miles. And so this is something that's a little bit more feasible for a consumer to use, whether you're using a drone for agricultural purposes or for real estate or something like that. These drones can handle wind pretty well, up to about 22 miles per hour, according to the manufacturer. And then we've got a smaller option by DJI. It's called the Mavic Air. You can see it's $919. So it's about half the price of the Phantom 4 Pro that I showed previously. It has a 21-minute flight time. It's got high speed, and it's got a pretty good range. A little bit smaller than the Phantom 4 Pro, but it's not bad. It also is good with handling wind. It can handle about the same wind speed as the Phantom 4 Pro. And both this one and the Phantom 4 Pro also have sensors on them that help them to avoid obstacles. So that comes in handy depending upon what sort of applications you're using these for. And then this last one that I'm going to show is kind of interesting. It's a small model. It's the DJI Mavic Mini. And with the smaller model, it's a smaller price tag, $399. It's less than 0.55 pounds. So what that means is that you can actually fly one of these without getting the remote pilot certification. That's also called the Part 107 certification. Also, you don't have to you don't have to register this drone either, because it's under that 0.55 pound limit or threshold. This one also gets pretty good flight time for a multi-rotor. It's 30 minutes. Maximum speed is a little bit slower than some of the others, and the range is pretty good. So it's pretty similar to the others. It can handle winds up to 18 miles per hour, so it's not as good at handling the winds. And it doesn't have the obstacle avoidance that the others do. And also, it doesn't work with some of the software, some of the imaging software that I'm going to talk about a little bit later. So again, depending upon the situation, this may or may not work for whatever it is you're going to use it for. So now I'm going to talk briefly about sensors. I think for a lot of times in some of the ag production, a lot of the farming operations that we have, we don't necessarily need sensors, but I'm going to talk about them as an option. So we use sensors because we want to look at images from different wavelengths. So you can see at the bottom, we've got on the x-axis here, we've got a range of different wavelengths. So we've got the visible light that we can see, and then we get into some of this near infrared spectrum. And so from plants, we don't really get a whole lot of reflectance. You can see the reflectance here in the visible light spectrum gets up to maybe 10%. And so that's one of the reasons why we get into some of this near infrared spectrum, because the reflectance goes up quite a bit more, and we can use that to see more things. So this is an example of some of the different ways that we use these different wavelength bands. So the NDVI is, a very common index that we use. It's called Normalized Difference Vegetation Index. And in this case, we're using two different bands of light. We're using the near infrared, and we're using the red light. And using this equation, then we can create these maps that provide us with information. And essentially, the NDVI information relates to the chlorophyll content of the plant itself. It's using the red light to capture that. And so depending upon the crops that are out in the field, you're going to use either an NDVI sensor or an NDRE sensor potentially. The NDVI sensor is able to to work under conditions where the plant is smaller. But as the plant grows, the red light spectrum becomes saturated. And so you actually have to switch to using the NDRE index that you see below, because that switches to using the red edge wavelength bands. And so those are much better and more sensitive to changes in chlorophyll at these higher levels of plant growth. And so this is an example of that. So here we've got a picture. We've got three different things. We've got the picture that you would get from the RGB camera. So that's the regular camera that just comes with the drone. And then you can see in the middle picture, this is using the NDVI index to create these maps and try to identify some different information than you would see normally under the regular RGB camera. And then the picture on the right shows under the NDRE index. And so this is actually a cornfield that's at the tasseling stage. And so the plants, much more mature. The plants are large. And so this is a situation where you would most likely want to use the NDRE index. And you can see why. If you look at the pictures, the one on the right is something where you can see a lot more variation and variability in the field. And so that can tell you a little bit more than the one in the middle, which really, is basically, pretty blue, and there's not much difference. And so that's why, we use some of these different indexes and different sensors for these things. So this is an example. I showed the Phantom 4 Pro before. And this is an upgrade that you can get from Centera. Centera is one of the leading manufacturers of some of these sensors, and this you can purchase either an NDVI or NDRE sensor, and it mounts right on the Phantom 4, as you can see on the right. Also, there are other kinds of sensors. These are called downwelling or incident light sensors. Essentially, if you're looking at taking images, from one day to the next, you're going to have changes in cloud cover. One day might be sunny, one day might be cloudy, and that's going to affect the reflectance from the plant. So how much light is being reflected and how it's being reflected. So having these light sensors also help to basically correct for any differences in cloud cover or in light. And so they can be kind of useful depending upon the situation. This is another example of a sensor, a multispectral sensor, where you've got, in this case, you've got 4 different sensors that can take images at 4 different wavelengths. And with this one, these are customizable, so you can pick which wavelengths you want to look at. A lot of other sensors, they're already chosen for you. So this is another one. MicaSense is another company that produces a lot of good sensors, and you can see these are some examples here, and similar in price to the Centera sensor that I showed before. The MicaSense Ultim actually has infrared bands, infrared imagery, and so you can look at things like heat and other things that are coming off of the plant besides the other bands that it comes with. But like I said, I think for a typical ag operation, you're not really going to need a sensor to really get the information that you're looking for. Really, when we're looking at using drones in agriculture, we're really trying to just pinpoint trouble areas so that we can get out there and find out more about what's going on at that location. And to do that, you can use, of course, the regular camera that comes with the drone, but you can also use some of this imaging software that can be useful. They can give you a little bit more information than what you're seeing through that video camera. So in this case, it uses the imaging software, uses georeferencing, so it can locate the specific point on a map in a field. And this is something that requires using a third-party software, unless you're good at using programs like ArcGIS, which is a little bit more of a complex program which requires a certain amount of training to use. However, these third-party softwares are available, and you can see an example. There's 4 that are listed at the bottom of the slide, and these are pretty user-friendly, and you don't have to have a whole lot of foundational knowledge to be able to use them. You just kind of play around with them, and they're like I said, they're pretty user-friendly, and I'm going to talk a little bit about these. So how would a farmer use something like this? So they could do a few different options. So one of the things that they could do is they could pay for subscription services. So these software are available as a subscription service. And so the farmer could purchase the drone, they could fly their field, and then they could use these software to be able to get additional information. Also, they could basically hire somebody to fly the field and take the images for them, and then the farmer could purchase the software subscription and do the imaging themselves. Or the last option is basically to hire a crop consultant who can do everything for you. They'll bring out the drone, they'll take the images, they'll use the software that they need to be able to collect the data. So like I said, a few different options depending upon how much you want to get into this. But the images that I showed on the slide are some examples of some of the data that you can get back from these software. So the example that I have shown here, this is a population map, a plant population map. So you can see it gives you an idea across the field of how these kind of populations add up. So when you're using something like this, basically what you're going to do is you're going to create a flight plan through some of these software, and that's going to set up, you're basically going to identify the field that you want to fly around, and it's going to go ahead, the software is going to go ahead and calculate how many pictures need to be taken and where the drone is going to fly across that field to take those pictures. And so you can see on this image that I've shown, the gold boxes indicate each picture that was taken across this field. So multiple pictures are taken, and they actually have to line up. There has to be a 75% overlap between images, so that then the software can take all those images and be able to figure out, similar to a puzzle, which ones go where, and then they can stitch together a whole map of the field. And so the software does that all for you, calculates, when the pictures should be taken, and it takes the pictures for you, and all that is free. You can do that with with a lot of the software that I showed before. Things like DroneDeploy and Field Agent can do some of those things where they just go through and you set up the flight plan and take the pictures. Like I said, that's the free part. It's when you get into some of the analysis afterwards that the costs come in. And so this is an example. This is an elevation map of the field after the pictures have been taken and the analysis has been done by the software. You can see the elevation, and then of course, as I showed before, the plant population. So this is an example from the DroneDeploy software, and this just kind of shows a little bit of how it works when you're setting up your flight plan. So it's very user-friendly. You can basically expand the window that you see there using the white dots that are all along that edge, and you can expand them or shorten them depending upon the area that you want to fly, and then it'll automatically place that green flight plan within that area, which is going to show you where that drone is going to fly to take pictures. And then a lot of times, if your area is larger than 25 acres, you're probably going to have to change batteries in between the flight. And so again, the software does it all for you. It indicates when the batteries are getting low, and then it will return to home. And then when it does so, you can change out the battery, and then you can see the little button, the blue button in the bottom right-hand corner. You basically just click on that button to restart your flight, and then the drone will fly back to the same spot from which it started, and it will finish that leg that it left off at. So the dotted line indicates the area that's already been captured with pictures, and then the solid green line is all the flight plan that still needs to be completed. But like I said, it picks up basically where it left off. And so this is an example of some imagery that I took and used with the Field Agent software. And you can see the image on the right is basically a stitched map. And so you can see all the different images that were taken. This was a 5-acre field, so a relatively small area, but the drone took about 100 pictures in about 5 to 6 minutes. And then once it was done, using the software, it stitched all those images together to create that map. And then also, it was able to provide me with some information here that focuses on the overall plant coverage or plant health. And so the redder areas indicate there's more soil showing through, and then the red and green indicate more of the plant that's there that can be seen. So it can give you an idea, just a snapshot across the field of how things are going. The DroneDeploy software has a feature in it where you can create a 3D model of the surface, which can be useful depending upon the situation. This is also, so this is what DroneDeploy looks like. This is the software once it's open and you've got your images in there loaded and analyzed. And so you can click on some different things on the left-hand side. You can see there's plant health there, and there's also elevation here. And so right now, plant health is clicked, and you can see this is the plant health map. So in this case, this was a field that was, recently planted. So the plants are very small, so you don't see a lot going on here. There's a lot of soil showing through, which is indicated by the red. But there is some green and yellow areas where some of the plants maybe are a little bigger, and you can see some of the differences there. And so this is just a zoom in on part of that field. You can see a little bit better some of the differences, some of the variability across the field, and then also looking at the elevation map. Comparing the two, maybe there's an effect of elevation on the amount of plant growth in some of these areas, especially early on in the growing season. So things like that you can get from these software that you wouldn't necessarily get from just using the video camera or the camera that comes with the drone itself. This is an example from the precision analytics software. And this is where you're able to look at different zones. You can create different zones to compare. And in this image, obviously, you can see just by the naked eye, you can tell there's a difference. But in some situations, you might not be able to tell, and that's where some of these zones can come into play and be useful. Basically, they give you a value or a number within that zone to indicate, the relative plant cover that's there based on the green that you see in the image that was created. So this is another example of creating some different zones. You can create these zones within the field, I think anywhere from 2 to 7 different zones, particularly in this Pix4D fields. And you can use this as a way of identifying, areas of the field that are doing better or worse. And so that can pinpoint certain areas maybe you want to get out and check into. Some of these redder areas are indicating that there's less plant material there. And so, or the plants aren't doing as well. And so those are areas maybe you want to get out and check and see why. And so you can see Pix4D Fields has this zone imagery that you can create. Precision Analytics also has something similar to that. It looks a little bit different, but you can see how it's broken up into zones. Field Agent also has a zone distribution like you see here. DroneDeploy has something, but it's not as user-friendly as some of these other softwares that I've found. So then once you've identified, maybe, when you were looking at you went out and you did some soil testing and you found that it was a nitrogen issue and you needed some more nitrogen in those areas that were redder. And so what you can do is you can create, within the software, you can create your own prescription plan. And so obviously the areas that are red, you're going to apply more nitrogen. The areas that are green, you're going to apply less. And so you can come up with a prescription plan. And then the data files that are associated with those prescription tables can be uploaded into any sort of equipment that uses GPS for applying herbicides or applying fertilizers or those kinds of things. And then you can actually apply a variable rate based on what imagery you got from the drone. So this is just another example. So this is a population map, similar to what I showed previously, but this is through the Field Agent software. So you can just see some of the different, the color scheme and how it matches up to the number of plants that are out there on a per acre basis. And then this is an example from the DroneDeploy software. So they work with this company called Agrimo. And so when you have the software subscription with DroneDeploy, you can use the Agrimo software as well. And so in this case, it's similar, same sort of thing we're looking at with the population, the plant population. So you can plug in, you know, how many plants should be there based on what you planted, how many seeds, and then it'll give you an indication of where you're at. And in this case, it's about 19% under what was predicted. So this last part is basically a table that shows the differentiation between the different software applications as far as the costs and some of the different add-ons or storage requirements that are part of them. So depending upon the application, one or more may fit. For example, the Field Agent software, it's got a lower price tag. It's only about $29 a month. But then if, you know, depending upon how many of the stitched maps you want, or how many elevation maps, or how much analysis you want, then those things are going to be extra. Whereas if you look at DroneDeploy, it's got a higher cost per month, but then a lot of that stuff is free. So with these software, different types of software applications, they all have a free trial period. So it's a good idea to, you know, if that's something that you think you might use with your drone, then it's a good idea to kind of try them all out and figure out, you know, before you have to pay anything, you can try to figure out what is going to work the best for your situation. All right, so that brings me to the end of my discussion on drone options and costs. I've got my contact information, so if anybody has any follow-up questions, please don't hesitate to send me an email or send me a tweet on Twitter, and I'll be happy to help you out. All right, thank you very much.